All right, so I just wanted to do a quick video to highlight kind of what we've been talking about with this. Why do we do what we do with different procedures in math class? And so today we're going to be focusing on why do we do what we do when we multiply decimals. Now, yesterday you should have completed the video looking at powers of 10 and how, since our number system is a base 10 number system, it involves moving decimal points around. So, for example, we talked about if you took 10 to the second, which is really 100, and you multiplied that by, say, 3.8 or 3 and 8 tenths, that 10 to the second is really moving the decimal point over 2 spots. So this would actually become 380 as an answer. So now as we're looking at this, we can actually use this to explore what happens when we multiply a decimal by a decimal. One thing we can look at as well, if you think, for example, if I had the decimal 3/10 and I multiplied it by the decimal 6/10, well, we've already talked about fraction multiplication. So if you think about it with fraction, we talked about that you can just multiply across. So when you do that, 3 times 6 is 18, and then 10 times 10 is 100. So then the answer would be 1800ths. So once again, you look here, the multiplication itself doesn't change. We have 3 times 6, which equals 18. It's just a matter of where does the decimal point go. So what we're actually going to start to look at is when we have a problem, for example, like 2 3/10 times 5. So we have a whole number 5. When we're looking at this, we can use estimation that 2 times 5 is 10, so our answer should be somewhat close to 10. What we're actually going to do is we're going to take powers of 10 and move our decimal point out of the way. So since here there is one digit behind the decimal point, we would actually multiply 2 3/10 times 10 to the first power, which is going to create the number 23. Since 5 is a whole number, it's just going to stay 5. And now my decimal point's back here, and I can just multiply like I would normally. So 23 times 5. So 5 times 3 would be 15. 5 times 2 is 10, plus 1 is 11. And now if you think about equality and undoing, if I multiplied by a power of 10 to make a whole number to find my answer, I need to do the opposite, and I'm actually going to divide by that same power of 10, which is going to move that decimal point, which is at the end right now, back that one spot. So in the end, our answer would be 11 5/10. And then if you remember at the beginning, we talked about that 2 times 5 is 10, so our answer should be close to 10. That answer seems reasonable. Now, many of your parents, and even myself, when I was taught to multiply decimals, I was told that you would just take, for example, 2 and say 27/100ths and multiply it by 1 5/10, and you just ignore the decimal points and you just count them. So like here, you would have 1, 2, 3 numbers behind the decimal point, and then I just put them back in. Now, I never understood why that worked or why we did it. I was just told that's simply what you do. And that's true, it's what we do, but the why behind it comes from those powers of 10. So since 27 is 2 digits behind the decimal point, we would multiply this by 10 to the second power to create a whole number of 227. The 1 5/10 is times 10 to the first power to make it 15. And so now if you think about it, we have a total of 10 to the third that we've multiplied by. So when I multiply, 5 times 7 is 35, 10 plus 3 is 13, 10 plus 1 I have 11, 0 placeholder, 7, 2, 2, and now I add. I have 3,405. But now because I used this power of 10 that I multiplied by, I'm going to take this, and when I move it back, I'm going to divide by 10 to the third. So it's going to move back those 3 spots, and we end up with an answer of 3.405 or 3 405 thousandths. And even if we look at using estimation to see if our answer is reasonable, 2 times 1 would be 2, so 3 would be a pretty reasonable answer in this case. So that's just the gist of why we do what we do when we multiply decimals. The rules themselves are similar to fractions and integers, right? So if we end up multiplying two numbers with the same sign, it's going to be a positive answer. And if they have opposite signs, it's going to be negative. And remember what we talked about back with the floats and anchors? It really comes down to vocabulary of like two groups of three, two groups of -3, and then we talked about like flipping two groups of three and flipping two groups of -3 when we multiplied the different things. But this is the gist and the summary of what we're doing with negative decimals.